Hi students, in today's session we are going to discuss about synchrotrons. When we discussed cyclotrons, we had seen that when the velocity of the ions increases to very high values, then there will be a relativistic increase in their mass. And when the mass of the ion increases in this manner, then the frequency of revolution of the ion will decrease. That is, the time taken by the ion to move in the circular path becomes larger, so that there will be a mismatch between the time taken by the ion to move in the circular path and the time period of the oscillating electric field. അതായത് അയോണിന്റെ വെലോസിറ്റി കൂടുമ്പോൾ അതിൻ്റെ മാസും വർദ്ധിക്കുന്നു. അതോടുകൂടി ഈ അയോൺ ഈ സർക്കുലർ പാത്തിൽ കൂടി കറങ്ങാൻ അല്ലെങ്കിൽ നീങ്ങാൻ എടുക്കുന്ന സമയം കൂടുന്നു. And there will be a mismatch between the time taken by the ion to move in the circular path and the time period of the oscillating electric field, so that the ions will lag behind the applied potential and they will not be accelerated further. Now, to prevent this, one of the suggestions was to vary the magnetic field. That is, the frequency of revolution of the ion is maintained a constant by increasing the magnetic field, so that B into root of 1 minus V square by C square term in the equation for frequency remains a constant. And those kind of particle accelerators in which the frequency of revolution of the ion is kept a constant by varying the magnetic field is called a synchrotron. Here we have to learn about two types of synchrotrons. One is the electron synchrotron and the other one is the proton synchrotron. Here I have shown you the figure of an electron synchrotron, and its parts consist of a main accelerating tube or the torus. It's in the shape of a torus made of glass or plastic with a semicircular D made of a metal. An alternating potential is applied to this D and the magnetic field is applied perpendicular to the torus. The magnetic field is a varying magnetic field. Now, the electron synchrotron is based on the combined working of a betatron and a cyclotron. Now, the radius of the orbit along which the ion is accelerated is kept a constant by increasing the magnetic field, just as in a betatron, and the increase in energy takes place when the ion enters the D and when it leaves the D, just like in a cyclotron. That is why we told that it is working on the combined principle of both. That is, the electron synchrotron works on the combined principle of cyclotron and betatron. Then the electrons after acceleration are made to strike the required target. So I think electron synchrotron is clear to all of you. The next kind of synchrotron that you have to learn is the proton synchrotron, and it is also called bivatron. In the proton synchrotron, we'll first discuss its parts. Again, it is a particle accelerator to provide protons with very high energy in the order of a billion electron volts. Here, the bivatron magnet consists of 4 segments connected by 4 equal straight magnets. These are the 4 equal straight magnets. And there is a ring magnet. So this the segments that we told are the quadrants of a circle of radius 30 feet each, and the connecting straight sections are of 20 feet each. So the bivatron magnet consists of four segments, the segments which are the quadrants of a circle, which are connected by straight sections. The straight sections have an arrangement for applying high frequency alternating potential. The high frequency alternating potential is applied to the straight sections, and the magnetic field acts vertically upwards. Now, as the proton passes through a straight section, it gets accelerated and they tend to move in a bigger orbital radius. But the magnetic field also increases here at the same time to constrain the proton to move in an orbit of constant radius. The output beam consists of a series of pulses of protons, and by suitable arrangement, the high energy particles are extracted and they are made to strike the target. So once again, I'll explain. As the protons are injected into one of the straight sections, they are accelerated and they tend to move in circles of increasing radii. But the varying magnetic field causes the proton to move in an orbit of constant radius. Their energy goes on increasing because of the accelerating potential given to it, or sorry, not the alternating potential applied, and the high energy protons are then extracted by means of a suitable arrangement and they are allowed to strike the target. Next, the theory. How does What is the mathematics behind this entire process? Now, the frequency of revolution of ion in a circular orbit, we have already calculated that. In the case of a cyclotron, the frequency of revolution of ion in a circular orbit is given by n is equal to Be by 2 pi m. Now, I multiply the numerator and denominator by c square, and then I take into account the relativistic effects so that mc square can be taken as the sum of the rest energy, that is m0. There must be a c here. I've made a mistake. It's m0 c square plus t, the kinetic energy. So n becomes equal to the frequency of revolution of ion in the circular orbit becomes equal to Be by 2 pi m0 c square plus t. But this is the equation for the frequency of the ion, frequency of revolution of the ion in the absence of the straight sections. Here, our proton synchrotron consists of uh, quadrants as well as straight sections. So we have to take into account the presence of these straight sections also. So in the presence of the straight sections, the frequency is written as, or it's obtained as BEC square by 2 pi into M0 C square plus T into 2 pi small r0 divided by 2 pi r0 plus 4l, where r0 is the radius of these quadrants and capital L is the length of the straight section. Now, how do we get that? For a given velocity, d is equal to vt, or length is proportional to the time. So, if small t is the time period taken to follow a circular path of circumference 2 pi r0, Then let t dash be the time taken to describe a path of 2 pi r0 plus 4l, that is including the 4 straight sections. So that t dash is equal to 2 pi r0 plus 4l by 2 pi r0 into t. We have simply followed ratio proportion. So that the frequency will be given by its reciprocal. N dash is equal to 1 by t into 2 pi r0 by 2 pi r0 plus 4l. But what is n by t? N by t is the frequency. So frequency n for only the circular path. N represents the frequency when the path followed is only circular, and that is given by BEC square by 2 pi m0 c square plus t. So n dash is equal to that frequency along the circular path into 2 pi r0 by 2 pi r0 plus 4l. So this is the frequency of revolution of an ion in a proton synchrotron. Now, if the proton is to move in an equilibrium orbit, then the relation between P and B, that is the applied magnetic field and momentum, is given as momentum equal to BeV. That is simply obtained from mv square by r0, that is centripetal force equal to BeV, the magnetic Lorentz force. So from that you will get P is equal to Be r0. If T is the kinetic energy of the proton of momentum T, then T plus m0 c square is equal to T is written in terms of momentum as Pc square plus the rest mass energy m0 c square, the whole inside the root sign, the square root of this whole term. So T plus m0 c square is equal to Be r0 c square plus m0 c square the whole root. Now squaring on both sides, you get t plus m0 c square the whole square is equal to the square of the terms inside the root. You just open the brackets, do the squaring, rearrange, you get the value of B to be, that is how the magnetic field should increase with kinetic energy. That is how it must vary. B is equal to T into T plus M0 C square, the whole thing inside the root, divided by ECR0. So this is the how the magnetic field should increase with T, so that the proton remains in a field of constant radius. So this gives us the mathematical theory for the working, or mathematical theory behind the working of a proton synchrotron. So we have discussed in this session what are synchrotrons, how the working of an electron synchrotron, the mathematical theory, as well as the working of a proton synchrotron. I hope this session is clear to all of you. If you have any doubts, please do contact.